It's a nice little slide. Basically, I think you know almost everything from this slide, so I'll take you quickly through this slide. It's just called, the slide is called vectors and coordinates. It's another thing we can attach to vectors. Normally, it is done like this. I mean, in three-dimensional space or in two-dimensional space, which is a subspace of three-dimensional space, you do like this. If you have a vector, which you know, it's denoted, we denote with an arrow. And if you put this arrow within the three-dimensional Cartesian coordinates, you can supply the endpoints of your vector with coordinates like this: x1, y1, z1, x2, y2, z2, and then you can, after you associated coordinates with the endpoints of your vector, you can associate the coordinates with the vector itself. And the process of this association is very simple. Here it is. You just take the corresponding differences. Just take the corresponding differences. You have to be careful, of course. You always subtract the origin from the endpoint of the vector. Some of you will make such mistake once, I'm sure, but just be careful. When you have to take the endpoint first, the origin second. Now, having the coordinates associated with the vector, operations on vectors like addition, subtraction, scaling can be done then in pure coordinate fashion, in pure algebraic way, without any reference to the geometry or geometrical nature of those vectors. And that's the reminder how we do that. If I have two vectors and each of them has associated triple of numbers, three coordinates, I have to comment on four things: identification, addition, subtraction, and scalar multiplication. All of them are presented here. We identify vectors in coordinate sense by just identifying the coordinates each by each. If they equal to each other, first, second, third, vectors are equal. We add vectors just by doing pure coordinate addition, first with first, second with second, third with the third. Similar goes about the subtraction, and similar goes about the scaling. So in terms of vector operations, coordinate side of the vectors is much more boring than geometrical side of the vectors. But still, I mean, it's still something we have to be aware of. The other thing which probably you should know, I mean, you know, but I'll just remind this for you, that the length of the vector, and that's a typical notation we're going to use for the length of the vector. Look at this. It's a vector with the two vertical bars around it. If you have the coordinates associated with the vector, finding the length, it's a very easy task. You just have to use the Pythagoras theorem. You don't have to even say the Pythagoras theorem. You just have to use the direct formula like this.